Hi everyone. So today's video is on a concept called synthetic division. And unlike the other videos you've watched for this SAT prep stuff, this is actually a new concept for you. You have not seen this before, okay? And that brings us to confession time. I probably should have shown you this method back in chapter 9 when we were doing all of the polynomial long division. I kind of kept expecting it to come up in one of the lessons we were doing or one of the examples. I expected them to lead you into it. And then by the time I kind of realized that it wasn't going to come up, we were already so far into the chapter that I felt like I really just couldn't throw one more thing at you. But this is another way to do polynomial division, okay, other than long division. Now, before you all start sharpening your pitchforks here and chasing me down, this only works in certain situations. Specifically, it works when the factor that you're dividing into the other, meaning the one on the outside, is linear. So this wouldn't work if you were trying to divide like a quadratic into a higher degree polynomial. Okay, you have to have a linear factor in your problem. So let me give you an example of what that would look like. So something like this, okay? And if you remember back from chapter 9, how we have done this up until now is we would set up a division bracket with this on the outside and this big thing on the inside, and we would say x times what is x to the third, and we'd put it up top, and so on and so on, okay? So again, this is an alternative to that, okay? And it would work on this one because this right here, this x plus 3, this is a linear factor. Okay, meaning it has a degree of 1. There's no exponent on the x other than a 1. Okay, so it only works when you have a linear factor. The reason for that is synthetic division does not use the factor, it uses the root. And we spend a long time talking about the relationship between a factor and a root. So if x plus 3 is my factor, my root would be negative 3. Okay, do you remember all that where we said like x plus 3 equals 0? And then we'd solve that and we'd say, okay, so x plus 3 equals 0, and that means that x would equal negative 3. Okay, so when you have your factor, you have to be able to look at it and say, okay, I know what my root is. And you're really only able to look at it and do that with a linear factor. Quadratic factors, you're going to have to do quadratic formula or something gross. So here's what the setup looks like. So we're going to start with that root that we just talked about, that negative 3. And we're going to put it in this fancy little box over here. I don't know who came up with the box idea, but they did. And then you want to take the coefficients off the polynomial that you're dividing into. So remember, coefficients are these numbers that are in front of the variables. Okay, so I'm going to take those 4 numbers, 1, 7, 17, and 15, and line them up here. 1, 7, 17, 15. If any of those were minuses, I would need to make sure I put negative numbers in. Okay, I'm going to leave myself about a line of space and then draw this line, okay? Because we're going to be putting numbers in here in just a second. Okay, first thing to do is always take this very first number and just drop it straight down, okay? So I'm going to just bring that 1 straight down, okay? Now, I'm going to take that root that we have, that negative 3, and multiply it by the number that I just brought down. So I'm multiplying here. Okay. Negative 3 times 1 is negative 3, and my answer goes right here. And then, from here to here, I'm going to add. Okay, so 7 plus negative 3. Be careful, because if you're in the division mindset, you might be thinking subtraction, but you are just combining here. You are adding. So 7 plus negative 3 is 4. So that's a 4. And now I'm going to repeat the process. I'm going to go negative 3 times 4 is negative 12. I'm going to put that here. And then I'm going to add going up and down. 17 plus negative 12, or 17 minus 12, is 5. Okay. Once again, negative 3 times 5 is negative 15. And then when you add together here, you get a 0. Okay? And that's a good thing because this number on the end always represents your remainder. Okay? Okay, I'll tell you what the other numbers represent in a second. But a remainder of 0 means it divides in evenly. Okay? Now, it is possible to get remainders, just like it was possible to get remainders before, but this one is set up to divide in evenly. Okay, so let's talk about what these numbers represent. What this set of numbers is that you came up with down here, that's the coefficients on the answer to your division problem. Okay, and I know that sounds confusing, but bear with me a second. I started with a third degree polynomial, right? And when I divide an x into an x to the third, I always drop down a degree, right? Because I'm dividing an x out. So my answer is going to be something quadratic. My answer is going to be an x squared. You always drop this degree down by 1, okay? So what's going to happen here is this is going to be an x squared. This is going to be an x. This isn't going to have anything at all on it. And then again, this right here is my remainder. So my answer here to my division problem would be this crazy thing that's hidden in all these lines. X squared plus 4x plus. That's the same answer that you would have gotten if you had done this with polynomial long division. Okay? Don't worry, we're going to practice this again, but I just wanted you to see the process kind of laid out. Is, just to review, you take your factor, you turn it into a root. You put your root over here in the box. You lay out the coefficients from the original. Okay? Drop the first one down, that's kind of your starting value. You multiply, put your answer here, add together. Answer goes there. Multiply, put your answer here, add together, answer goes there. Multiply, answer goes there, add together, that's your remainder. Okay? And then again, this is always going to be one less in terms of degree than what you started with. So if I had started with an x to the fourth here, this would start as an x cubed, and then I'm just going to go down one each time. So x cubed, x squared, x, and then I would presumably have another number there. Okay? Okay, let's try another one. Okay, so here's a second example for you involving polynomial division here that we're going to use synthetic division on. And I want to point out a couple of things to you before we start. First of all, this one's written differently than the last one was. Typically with polynomial division, I guess I can't say typically, a lot of the times you see it written with the traditional division sign that we're all used to, right? But it could be written this way as well. This is sort of the way that we write other types of division in math. And I've noticed that the SAT definitely favors this style of division, so that's why I wanted to throw that one in there. The other thing I wanted you to notice, if you look at that polynomial on the top, you're missing a term. It goes from 4 to 3 to 2, but it's missing the x term here, okay? You have to compensate for that with a 0, just like you did in the other type of division, okay? And then the last thing is, this factor is good to go because it's linear, but remember you need to be thinking about what the root or the 0 is. So in order to do that, we would say, okay, 2x minus 1 equals 0. Solve for x. So 2x equals 1. And then x would equal 1/2. Oops, x equals 1/2. Okay, so you always want to be thinking about what would the root or the factor, or I keep saying that, I'm sorry, the root or the 0. What would the root or the 0 be? So this is what's going to start in our magic little box here. Okay, and then we're going to take these coefficients off, but of course we're going to remember that there's a missing x there. That's why I kind of underlined, looks like I underlined the plus sign, but that's supposed to represent the x that's not there. So this would be a 2, a -1, a 4, a 0, and a 5. So right now, if you don't understand where those numbers came from, just pause and look at this polynomial and make sure you understand where those came from before you go on. Draw my line, okay? Don't let the 1/2 intimidate you. It'll work just like everything else will. So I drop down the 2. I get a 2. I'm going to do 1/2 times 2, which is 1, and that goes there. And then I'm adding up and down here. -1 plus 1 is 0. Okay, that's okay. You can get zeros. 1/2 times 0 is 0. So then 4 plus 0 is 4. I'm going to stop drawing the lines because it's going to make my picture really messy. But 1/2 times 4 is 2. That goes here. 0 plus 2 is 2. 1/2 times 2 is 1. So I'm going to put a 1 here. Add together and I get 6. Okay, so these are going to be my new coefficients, these numbers down here. And remember that my new polynomial will always be 1 degree less than what I started with. So this was a 4th degree, which means this is going to start out as a 3rd degree. And so this is going to be x to the 3rd. This is going to be x squared. This is going to be x. This one's not going to have any x's at all. Okay? This is my remainder. And just like what we did with remainders before, we're going to put that, when I write my final answer out, I'm going to put that over the divisor, which is the 2x minus 1. Okay, so I'm going to write it as a fraction as 6 over 2x minus 1. Okay, so when I write my final answer, it would look like this. 2x to the 3rd. 0x squared, I don't actually have to write that in there. Okay, so I would just go straight to 4x plus 2, and then plus 6 over the divisor of 2x minus 1. Okay, so this one did not divide in evenly. This one did have a remainder, but you treat the remainder the same way you did with polynomial long division. Okay, so why don't you give this a try? And I'm showing you this now, not because it's critical, because you could still, I mean, if you hate this method, you could still use long division on everything. But I know that on the SAT, there's a time crunch. And so if you run into one of these long division problems on the SAT, which I have seen a few, you may want just a quicker way to go about it. So give the synthetic division a try. I think you've got 4 or 5 to try there on your own, plus a couple that I pulled from the SAT packets. And if we need to go over this some more next week, we definitely will.